right. Great. I'm trying to. I did Twitch a few times in the distant past. Dot Morton, thanks for letting me know that I'm getting this right. Although it still shows 0 viewers, so I'm not sure how to read that. Anyway, let's see. Yeah, I believe it. 9 viewers. Wow, that's great. Well, go ahead. Those of you who came a bit early, I started this a couple minutes early. You get the early chance to write in the topics or questions you want me to cover today. I have a long list of things to cover as well, but I definitely want this to be interactive and answer questions so that it's worth your time. Give everybody another minute or so to show up here. Camera's really blurry right now. There we go. There's a lot of flags that are ints instead of enums. How can I contribute these? Couldn't figure out where to plug that in. That's a good one. We will definitely cover that. All right, well, let's get started. So, the first thing I wanted to cover was a quick demo for those of you who may be new or may not have seen previous demos. I will make this quick so it's not too boring. But we start with a C# project. This is just an ordinary C# project that has a reference to the Microsoft Windows CsWin32 package. That's really all you need. And then these represent some p-invokes that I'm going to enable. I'll start with the very simplest one. This isn't even a p-invoke, it's just a constant. I have a native methods.txt file in my project, so I can just uncomment out SOK. And in a moment, that compile error went away, and SOK is now defined. You can see that's set to be a 0. Also, if you're using 16.9, you'll see in the Analyzers node in Solution Explorer that a file showed up under the source generator. So you can actually use that to easily open up the source generated file. And so we see here now, I did not have to write this. This is in my project, but it's not checked into source control, that it defined a file with SOK equaling 0. Now, if you're not using 16.9, you can still look at that file by going to definition on that constant. It'll take you to the exact same file. So this on Solution Explorer is just a convenience so that you can see what files were generated. But a constant isn't all that interesting. So let's go on to get tick count, which is a very trivial p-invoke. So we'll enable that too. Notice I'm not even saving these files. Since as a source generator, Roslyn has it all hooked into the IDE so well that all you have to do is make a character change and it immediately shows up. So now in addition to constants on the right, I have p-invoke kernel32 because kernel32 is the module that defines get tick count. So I can bring that up, and we can see it defined the get tick count extern method with the DLL import that's required. It even includes XML doc comments. So now I can hover over that and see the docs, and it includes a link so that I can immediately read the rest of it, because all these comments wouldn't be great to read from an IntelliSense pop-up window. So it helps you with that too. Let's go on to something more interesting though. So far it's one for one. I asked for a constant, I got a constant. I asked for a method, I got a method. Now let's do something a little more interesting. Let's ask for create file and see what that did. So it's still kernel32, so it just added to this existing file. I'm going to collapse the definitions here for a moment. Several things happened here, and we'll go over them more in detail later, but we got a create file method. In fact, we get it twice, here and here. Excuse me. And we get safe handles. We get a native, basically the extern method, that has the same signature as the native method did originally. And then we have a more friendly overload that uses safe handles, more managed friendly types like string. We didn't get that for get tick count because it turned out there was nothing more to make it easier. It was naturally easy. But whenever there's something hard, we want to offer an easier overload as well. This adds a bit of marshalling. This is down bare metal stuff. So you can use this when for some reason this doesn't fit the bill, whether it's for performance reasons or you need to pass in raw handles or whatever it is. See, Mike says Andrew's working on some automation here to add more enums. Yes. So we're going to cover that a little bit later, Mike, but you're absolutely right. The other thing we got is close handle. We didn't ask for close handle, but whenever you call create file, you're given a handle that you are responsible to close, and so we infer that and give you what you need. The safe handle, of course, takes care of that as well. The other thing you get is a bunch of enums. So let's go ahead and actually uncomment this. So the method actually includes several enums with all the right constants in them. So here's file access flags. So actually you see on the right we got a bunch of different files created, one for each type, which is great for discoverability. And again, on the overloads here, you can see we have both available, both discoverable, both have docs on them. And one nice little feature is because of the way we're doing the friendly overload generation and doing the marshalling of safe handles ourselves, you actually can pass in null. .NET Interop doesn't let you pass null in for a safe handle, but we let you do that. So that's great. And finally, unfortunately, file flag delete on close should be in this enum, but it's not. And so I declare that constant myself. Now I want to, as we go into this, I'll show you how you deal with some of these things. This is an early preview, right? It's not complete. Enums are missing, constants are missing, some methods are wrong, some structs are wrong, some things that vary between 32-bit and 64-bit aren't quite right yet. We have an amazing amount of coverage as far as API coverage. And our goal is to get correct, complete coverage of all of the header files into this intermediate format, which is what we call the metadata. It's a WinMD, which then lots of different language projections can create C# projections for, which is what CsWin32 does, and we'll go more into that. Looks like WinUI still doesn't fully work with this in VS 16.9. Last I heard, WinUI was working, so we'll have to look into that more, and please file a bug if you'd like, so we can investigate that more. So as I mentioned, with the multiple overloads, one of our design goals is this should provide the lowest level access that someone might need. We don't want people to have to write their own P invokes. We also want it to be very friendly and easy to use. We need to start with accuracy first, and then we add the friendly layer on top. So in some cases where we can be friendly and pretty confident that we're doing it accurately, we've already got the friendly overloads. In other cases, you'll maybe wonder, hey, why isn't this friendly overload here, or why isn't it friendlier? That's a point in time thing. We're working on it, but feel free again to file issues if there's particular examples that you think we may have missed. I haven't. Let's show a struct here. There's a popular one that's been going around. We've been discussing. Bitmap Info is a special case. So after I just type that, I'm just waiting a moment for it to show up here. There it is. Bring it out here. So you see we do structs as well. Now if I knew the API off the top of my head that uses this struct, I could have just asked for that method and it would have generated the supporting structs automatically. But just as an example, we do structs. We make all of our types partial. So one of the things that you can do here is, let's go back to over here, and we're saying, let's consume this struct, bitmap info, bi. Now let's say I wanted to add a method to this to make it more friendly that the projection didn't do. Let's is valid, for example, or I could even make it a property. Bool v equals this. So I just need to go, I could start over here. This is probably the easiest way to do it. Let's copy the namespace over, copy the struct partial there, and then I can say internal bool is valid, true, and now we've got it. Now, one of the interesting things is, so the source generator, it will allow you to add within the project, but it also will suppress generation of code when you already have it defined. So I think this will work. Let's see. Let's take away partial. I'm basically now claiming that I'm going to generate it entirely myself. And let's see if that works. Sometimes yep, it's gone. So if you want, if for example you were using CsWin32 and you were pretty happy with it, but it got something wrong and you needed to unblock yourself in the meantime, all you've got to do is copy it out. It's still showing me, but it's a yellow window saying that I'm not generating this anymore. Just so you know, it's actually not generating this. But you could copy and paste what is here into your own code, fix it, and then the source generator will quietly just stop generating that type. So you don't get, this type is defined type errors. This also lets you write a library. So if you liked the projections, but you didn't want the projection into every single one of your projects, you could create a new CS project, project the code into that one, and then just have a project reference to that library from all of your other projects. And then they consume these types as a library instead of projecting into each individual one. So that's an option for you, which is actually a good lead into, this is internal though, which doesn't lend very well to a library. So let's see how to fix that. We can create a new, add a JSON file to this. We'll call it native methods.json. And I have to look at the name. We haven't actually published the schema in a public, well, it's in the repo, but it's not easy to find yet. There. So now I've got IntelliSense and I can say public true. And now if we go back and look, notice all these types and methods are public now. So by default, anything you project is yours private use for your assembly. But if you wanted to write a library that exposes these interop types and methods, you're welcome to do that. As you can see, there's several other options where you can tailor this if you'd like. But that's probably beyond the scope unless you have specific questions. Let me catch up on some questions here. JNM2 asks, I wonder if VS offers create property and whether it would start a new file. That's a good question. I haven't tried that. Let me know what you find out. Can I make specific types public instead of all or nothing? No, not today. That is something that we might end up doing. When we talked about Comm Interfaces, we'll talk about more specific type tailoring that you might do. Yeah, we don't do. I'm curious about your use case too, Morton. You might file an issue on the GitHub project so we can have a discussion about that. Oh, I'd maybe just want to expose the enums, but not the actual interop methods. Yeah, I could see that. That's a good one. Something else that we do, you'll notice that this safe handle that we return, that's a .NET type. We didn't actually generate that because safe file handle comes from .NET and already does what we need it to do, so we reuse it. That way you could call create file and then pass this handle to other .NET APIs that aren't CsWin32 aware, and they'll just accept the handle. But in most cases, there are dozens of release methods, so we need dozens of different safe handle derived types, and .NET doesn't expose almost any of them. So we actually we'll code gen up a safe handle and then return that type when we need to. All right, let's see. Comm interfaces. Let's show that off real quick. iSpell checker is one that Mike has used in his demos a couple times. And I'll just wait for that to show up here. By the way, the perf on this, it's decent on my machine at least, but we do have an open issue to track perf on this, there are gobs of opportunities to improve perf. So if you use this and on your machine it's slow, not to worry, we will. We're aware of the problem and we'll get to it for sure. And there's lots of reasons to believe that we can make this a lot faster. Right, so here's the iSpell checker interface. You're going to notice right away it's not an interface. Again, point in time thing. Although I will say, I've never understood Comm more than I do now, because you've heard of vtables and things, but we often don't actually get into them. This is what the Comm object looks like, or at least the pointer that you get back from a query interface call gives you back a pointer to a vtable, and this is exactly the contents of the vtable. You'll notice it's flattened. Query interface, add ref, and release ref are all from IUnknown. When you have Comm interfaces that inherit from IUnknown, which they all have to, it just gets flattened. Every vtable has to have all of its base types listed. So this is a C#9 syntax for native function pointers, which we use at the moment. And then we have a struct called iSpellChecker that will look at the vtable and directly invoke into it. There's no marshalling here. Function pointer invocations are the very, very fastest thing you can possibly do in interop in .NET, and it's new in C#9. That said, structs are really bad at being Comm objects. You have to be careful to always reference it by its pointer. I'll bring up an example. And again, this comes from Mike's sample. So here we create the iSpellChecker factory object with co-create instance, which is yet another generated pinvoke method, and we pass it an out pointer, which is to a struct actually, and then you can call it just like any other Comm object. This looks very, very, very much like C++ with the arrow syntax. That's how you invoke methods by dereferencing a pointer. And if you wanted to get a different interface on the same Comm object, you'd have to call query interface. At the end, we have to call release, which it doesn't look like we're doing, so we probably have a bug there. See, we re-release other things, but not the spell checker factory, evidently. So all those types of things you have to worry about when you're dealing with structs. So in a future version soon, we will be generating Comm interfaces, or at least the option to generate Comm interfaces, and probably that'll be the default. And then you can let RCWs handle all of the work for you, and it just feels much more like a managed object. JNM2 asks, is the Comm interface projection at a point where it could implement Vista-style file dialogues? I was a little intimidated, not sure if I should try to use this instead of my own Comm declarations. If it's in the Win32 headers, so JNM, if you've got an example of the actual type name, we can paste it in. I do this a lot, and you might find it useful too. So I mentioned the metadata, this intermediate format. CsWin32, everything it generates, or almost everything it generates, is based on the metadata, which is a NuGet dependency of CsWin32. So you can open up the metadata here and search for something. So I can look for iSpellChecker, and you could look at the interface. So you could look to see if the Comm interface for, okay, there we go. Thank you, JNM2. Let's look at yours. iFile dialog events. So it's there. So there's a good chance, I sure hope, it would be easier for you to just type iFile dialog events into the native methods.txt file, and then we would generate this interface for you. You notice even the metadata describes it as an interface. So it just makes things complicated for us in the generation. We want to make sure that whatever we generate, it compiles. And when you have Comm interfaces and then structs with fields that are Comm interfaces, marshalling gets involved, and then it just cascades, and a bunch of other things that we do end up generating compile errors. So we have to be careful when we do that. But I sure hope that this would make it easier. The other thing that we might do, I don't know how that happened. The other thing that we might do is give you a switch on a per interface method basis to turn on or off preserve sig. So the way this is written here, this is all preserve sig style, right? All the methods return H result. With preserve sig turned off, which is what most people prefer, it feels much more natural to a .NET developer. Exceptions are thrown instead of an H result that you always have to remember to check. The out the out ret val parameters become the actual return value. It makes it a lot nicer, but sometimes methods will need to return s false, which in a non-preserved SIG world, there's no way you can tell that s false was returned. Or maybe the method regularly returns an error code and you don't want to experience those first chance exceptions. So we want to give you the ability to have preserved SIG off or on and say, look, I generally like it off, but for this particular case I need it on. We want to give you that. Let's see, Dot Morton says, I see you generate for Windows SDK 19041. Will this has the OS version attribute set, so we know if we so it's a Windows API level question. And yeah, one of the goals, I mean, .NET is so slow sometimes that exposing managed types and managed methods to access what Windows offers in a new version of Windows, and many times just .NET never, the BCL never covers it. So you need to be able to p-invoke to get those things. And so, yes, we want to leverage the new attribute and the analyzers that go with it so that we can generate all the members. But if you're targeting a particular version of Windows relative to the API that you're calling, you get a warning saying, hey, you're calling a method that might not be there, and then you can add the if check. So in general, the metadata that we're based on will always be based on the latest Windows SDK so that everything you could want is there. But as soon as the metadata has the attributes on the APIs to let us know which version of Windows introduced them, then CsWin32 can start generating those attributes as well so that you get those warnings. And in fact, we might even say, look, if you're targeting some maximum version of Windows, we won't even generate the APIs that you would never have. Looks like Mike addressed it in the chat as well. Okay, let's move on to let's just talk about the source generators a little bit more. So I mentioned that you can, let me bring this back up here. You can certainly go in and copy and paste the generated code and put it in your own project, and then you could turn the source generator off. That's an option. And you can use libraries that define this as well. I started the .NET Pinvoke project, and it was all handwritten APIs, and it was NuGet packages, so it was really convenient to consume, but our code coverage, or our API coverage, was like 5% in some cases. So it very often the method you need didn't exist. And so this is an effort to, let's get 100% coverage and reasonably easy, definitely accurate, fast APIs with easy APIs as well whenever we can, particularly whenever we can automatically generate it. When there's particular methods that have very peculiar behaviors, and there are quite a few of those in Win32, unfortunately, you're still going to need to read the docs and understand how to call the method and what the memory management obligations are, etc., like a C programmer would in some cases. Once we get everything down and stable and accurate, we can go back potentially, and at least in the high traffic APIs, we can look at adding more friendly APIs to make it. What we don't want to do is create a new BCL, right? So there's always going to be room for someone to create a higher level library that wraps interop APIs and makes them easier to use. We're not trying to become the only library that does everything you could possibly want. Some of the neat things that a source generator can do, though, when this runs, we know all sorts of things about your project. For example, I showed you how all I had to do was create a non-partial type, and suddenly it suppressed the generation of Bitmap Info. Recall that. Similarly, if you have nullable ref annotations turned on, we could start generating source code with nullable ref annotations. So you could know, for example, that file name must be non-null, but the safe handle could be null. And we could, if we generated that, or if you just included a source file directly, it would either have them or it wouldn't. And if it had them and your project didn't support them because you were using an older Lang version, for example, you just get compile errors or warnings. So we can do a lot to customize it. Also, if you're referencing a project that does define public APIs that were projected, or at least collide in type name and method name, we will suppress generating it in your local project because you're already getting it from a referenced assembly. So we can customize those sorts of things. Just to avoid confusion, there's not nullable ref support yet. We have an open issue for that. And again, those are the nice, really nice things that the icing on top that we'll do once we get everything accurate. And missing enums is hurting a lot of people, so that's where for example, that's one of our top priorities. All right, so let's jump back into, I'm not seeing a lot of, let's see, JNM did actually add another one. Does CS132 define interfaces that represent COM classes? So again, just to train you on where you could go to find that out, you'd go to the metadata, because if it's in the metadata, it should be in the CS132 projection. So I think we have a spell check. So we have iSpellChecker, but we also have, in particular, a spell checker factory. And that's actually what Mike used in his demo. Let's see here. So spell checker factory, that's useless except for the struct. So that's kind of like the UUID of in C++. So if by co-class you mean can you, I have seen some syntax, I think, where you could say new spell checker factory or something, and I think the co-class does magic to make that work. I think I've heard that CsWin32 offers that, just the new object experience. We don't do that today in CsWin32. CsWin32 actually documents every interface that's going to be on that object, so it's plausible to do that. With CS132, we're dealing with header files that there is no authoritative, these are all the interfaces that are implemented on an object. So if we created a co-class that you just knew up, what you have is a type of that class, and then it would just thunk every method call over to the actual COM object, and then your typecasts might fail. If you're casting it to iSpellChecker2, and we didn't know that the co-class was supposed to have that interface on it, the cast would fail, even though if you cast the original COM object, it would succeed. So that's a problem I don't know if we're going to be able to generally solve. So we're probably going to just have you do something like this, maybe something easier than this, though, where you actually get the RCW itself back so that all the casts succeed. Yes, JNM2, activator.create instance is fine. In fact, we could replace this method with activator create instance, and the rest of this would probably work just fine. Well, except that I guess once we get interfaces that are actually interfaces instead of structs, you could make activator.create instance work. It gives you back an RCW. You could get the int pointer from that RCW and then cast that int pointer as one of our struct definitions, and it would work, but I'm not sure why you do that, because we want to make it easier anyway. All right, so let's jump back to the extern methods, though. Here. Okay, so if you haven't looked at the C, maybe you're not a C programmer, just so you know what some of these things are. C has a lot of different, it has no native string type, at least back in the C days it didn't. And so there were lots of definitions of various character arrays and pointers to character strings and things. This is one of them. This is a pointer to a constant wide char string. In other words, it's a char star. But some of there were lots of different type defs for char star in C++, and different ones came with different meanings, like who was responsible to free the memory and how should it be freed. And so we retain all that here. And if we look at this definition here, we do what we can in this struct. There's a lot more in this struct than is in the metadata. We want to make sure it's an idiomatic experience in C#, as I mentioned, and that's absolutely a work in progress. We've got a long way to go. But this struct that you get will give you the length of the string, which is null terminated, because that's the rule for PCW strings. And it also has some implicit and explicit operators so that you can pass in a char star and it just works. And it'll trivially create a .NET string for you if you just call .toString on it. We have something that will return a span, so you can get access to the characters easily without any object allocations. So we've got a lot of options there. But one thing to know is all of these structs are, at the moment, they are all blittable, which means you're allowed to take a pointer to them. And that just opens up a variety of perf optimizations and keeps the extern method very, very simple. And then we do the magic here in this friendly overload. So a string here, that needs to be marshaled into native code. So in this case, we take the pointer to the first character, and we're going to pass that into the extern method. Now this is safe because we know from this type it's a constant string. The method will not mutate the string. In another pinvoke method where it takes a pw stir, no c, and that tells us that the implementation will mutate the string. So our friendly overload won't take string because .NET string is supposed to be immutable. So at that point, at the moment, we still just takes char star or pw stir. Later on, we might take a span of char. Maybe we do that already. But we'll have some other option for you to pass in a mutable character buffer, which you can then turn into a string when you're done, if that's what you'd like. So Don Morton, there are several of these cases where using arrays or strings have to be ugly, unsafe pointer code instead of using arrays or string builders. It creates some ugly, hairy code to use just to get potential perf movement. Can we have both? Yes. So we have one overload right now. In the .NET pinvoke project, we had lots of overloads. Like some pinvoke methods actually had like 5 or 6 different overloads. And it got to be a real problem, actually, because, for example, if you had an overload that took safe handle and another overload that took something else, and you passed in null, then C# wouldn't know, did you want to call the safe handle overload or this other overload? And so you'd have to start casting your nulls, which is really, really gross. So at the moment, we're erring on the side of fewer overloads. So right now, we just have a fixed, there is one friendly overload. So we have to make certain policy decisions that way so that there's never a ambiguity in the compiler where you have to start casting things. But it is likely that we'll eventually have more than one friendly overload as long as we can be reasonably sure that you won't get these weird ambiguities that require ugly casts. So, for example, a mutable string, we might want to take a span of char, and we might have another overload that takes a string builder, possibly. That said, string builders are pretty inefficient at what they do. When it comes to interop, you have to copy the whole string to a new contiguous buffer that you can point at, and then copy it back. Whereas if you just do a span of char, there's absolutely no copying. And something else I want to throw out there, when I started doing a lot of interop work a few years ago, I tried my best to avoid unsafe code as well. It turns out unsafe code is a lot easier than safe code when you're doing interop. So if you and VB coders have my sympathy because they don't have pointers as an option. But if you go to Marshall, for example, and you say alloc h global, and you say I want 15 bytes, and then you have to assign this to a pointer. Now you have to go try finally, like you really should do this every single time to make sure that there's no way you're going to leak native memory here. Free h global p, right? And then you can use your local here. Yeah, exactly, JNM. Int pointer is the real unsafe. So now you have to, if I had a struct that I wanted to have a pointer to, now I have to say Marshall dot struct. Let's see, struct to pointer. I pass in my structure, new, say Bitmap Info, all initialized, and then I pass in my p. And by the way, now I have to say, okay, was it size of p there? Oh, size of Bitmap Info. Right. You get the idea. Like you have to do all of the special marshalling stuff to get data into the pointer, and then you have to call the method that takes an int pointer instead of a void star, or ideally it would be a bitmap info star, right? The alternative to this is trivial, right? If I was willing to do unsafe code, it becomes bitmap info pbi. Forget the star. Yeah, just bi. Equals default. You initialize it the normal way, and then you finally just call your method that takes a pointer, and you say pound bi, and that just works because this is a local, so it's inherently pinned. Or if it wasn't a local, then you can just do a single fixed call to get the pointer and then call the pointer. But you notice there's no try-finalies, there's no marshalling, there's no danger of leaking native memory because you never allocated any. Turns out that the code you called just want a pointer. They don't care if you used alloc h global or whatever else. All right, so JNM says, just from that perspective, I always wanted char star or char array over a string builder. Nowadays, what I want is span of char. Yes, exactly. So I definitely want span of char and read only span of char to be options. Again, we want to make sure that we don't have too many overloads. String builder is an interesting case. We had a long discussion on GitHub about it, so I won't rehash that here. We may offer string builder overloads, but not right away. Typically deal with string types in .NET. Doesn't matter if my code or the generator converts it. Same cost, so move the dev cost to the generator code. Absolutely. Yep, exactly. Which is why we have, wherever it went here. So if we drill into create file, it's doing the string arithmetic, and here's our safe handle code, by the way. I mentioned we don't, the extern method doesn't take a safe handle. It takes the native struct, the type def that you would take in native code. And that's useful because sometimes you just have the value for the handle and you don't have a safe handle, and you don't want to create a safe handle object just so that you can pass it in. So that's useful. But the other thing that this does, .NET assumes that all safe handles represent int pointer sized handles. But it turns out that not all handles in Windows are int pointer sized. Almost all of them are. But for example, MSI handle is not. So you can't build a safe handle around MSI handle and expect it to interop properly. So we don't. Also because null safe handles throw a null reference exception by .NET, the interop layer. So here we say this is a safe handle. We check if it's null, we just use the default handle, like the 0 handle. But if it's non-null, we do the marshalling of that into whatever sized handle the native code wants manually. The other nice thing is, although this is what basically the .NET runtime would do, like if you said, well, why don't you just define your extern to take all those safe handles, all these nice things? Yes, you can do that. Then .NET has to do code gen on the fly at runtime, which makes the first invocation of your interop method slow. It also blocks your app from working on AOT environments like iPhone. So doing this actually is setting us up for success, setting your app or library up for success to run in some of those other environments. At high performance as well, but just be able to run it all in some cases. The last two parameters of create icon are 2 byte star parameters instead of byte array. Again, makes for ugly code for me. Yeah, I get that. So in the byte star case, what you would let's try it. Let's actually see. Let's see if we don't yet make that better. So here's create icon. Ooh, nope, that was something else. I'm just going to do a navigate to and find out where it went. Okay. So, oh, that's interesting. Is this supposed to be the array? Because in byte doesn't make any sense. That's probably supposed to. So let's go to the metadata. Not that the metadata is always right yet, but it's part of the story. That's our input. That was create icon. So byte star. So we knew it was we got the in right as far as it's a pointer to a byte, but yeah, see the metadata just says it wants a pointer to a byte. It's missing the native array info attribute. So that's a bug. So this is what you do when this happens, okay? So I don't mind at all if you file bugs against CsWin32, but when you do, you might often find that we move your bug to the metadata project, and that's why we do it. So I'm going to go to Win32 metadata. Let's put this in first and see. Okay, there's no bug for it. So create icon, and I'm doing this in front of you because you brought it up, and so that you're all very comfortable doing this. And I know, especially you, Morton and JNM2, you're already active on this, so you know what's up. This is for everybody else. Missing native array attribute on byte array parameters. So I might do this. Currently, the metadata has but the last two parameters should be arrays. And that's it. And Steve, who owns the metadata, does a great job at getting. I mean, he's got he tries to keep it under 100 issues. He's ripping them out, like fixing up a lot, but you know, he's got thousands of APIs to own and fix all this up. So be patient as he fixes them. But that's how you know whether it's like a CS132 issue or a metadata issue. If the metadata looks wrong, then CS132 can't do any better. The other thing to keep in mind is this is a WinMD. This is not a .NET runtime assembly. Okay, so you can't just reference this metadata and expect it to work in your app. It won't work. It is just a database for symbolic information. And in particular, it does things that C# can't do. So right now we're looking at a C# decompiled view of this method. But sometimes that's going to lie. And what you really need to do is look at the IL to see, oh yeah, okay, this is right after all. It's just the C# rendition doesn't work out. Now, when the C# decompiled view isn't correct, it doesn't reflect the actual metadata here, that doesn't mean that CS132 has no hope of getting it right. In fact, we get most of it right at the moment. So, and we plan to get all of it right. We hope to. If you see something wrong, then let us know. But for example, C# does not let you represent fixed length arrays in structs, except using the fixed keyword, which makes them unsafe and other things. So you have to switch to IL to see that. And then in CS132, we do fancy stuff to make it work in C#, even though it doesn't look as easy as maybe you think maybe it should have. All right, good question though. I'm sorry, my throat is so cruddy this morning. All right, friendly overloads, we covered that. Safe handled. Oh, just one pattern you'll notice when we produce the safe handles, we produce the distinctly typed handle. You can see this is going to be a destroy icon safe handle. But when we accept handles, let's go back to this one, we take the base type. Now, there is absolutely a discoverability improvement or benefit to using the very precise safe handles in both locations. You could be like, oh, I need one of those handles. Well, what API produces that sort of handle for me? It can be useful. But because .NET already defines some safe handle types, or your code might define some safe handle types, there was no reason for us to limit it and require you to pass our safe handle type. We'll take any of them. But we will tell you what we're going to return, basically. So it's an adaptability thing. We want this API to be useful in the most scenarios. Sure, let's talk about enums. In fact, that is the next thing on my list. So here is the problem with enums. Enums don't exist in the C headers, which is where all of this is originally coming from. In fact, the set of constants that feed into what we would think of as an enum, they're not even constants. Most of them are defines. So it's really hard for the scraper to even get the values, which is why, for example, I showed you, this one we had to define ourselves, because it's just a hash define in the headers. And so it's just not there. Now, Steve is doing yeoman's work to pull out more of the constants, but the richness of the enums just isn't there at all. So what we're doing to fix that, because again, there are thousands of APIs and we want it to be accurate, we'd like to eliminate as much human error as possible. We want to get 100% code coverage or API coverage as much as we can. So we're actually borrowing a lot from the docs. Now, we already have a doc scraper. I mean, I've shown you that if you hover over this, you get these docs, and this text comes straight out of the same Git repo that drives docs.microsoft.com. So that's where that text comes from, but something else comes that's very useful. So see this flags here? That should be an enum in C#. If we scroll down here, here's the table of values, the names, the docs, and In this case, even the constants, like the ordinal values, although those are not always there. So if we could somehow collect from all the APIs where the documents seem to imply that there's an enum that should be here, then we could build that into the metadata as an enum. So we could change in this method, let's say set window position. Let's take a look at that right now. So you see, for now, that's just a uint, just like in the native code. But we'd like to change that uint type to be an enum and defined with all of these values here with the values documented. That would be awesome. The way we're going to do that en masse is scraping the docs because the header files just don't have the information. Now, the docs are not always complete either. This doc was written at a particular point in time, and it's quite possible that later on the header file added one more value that should be in this table but isn't. So this is where we really need your help, because the header files don't have it, the docs don't have it. Now, the header file might have the constant, it just doesn't have it belonging to an enum. So we're going to do what we can in the next, and you should see an improvement in the next week or two, I think, where a whole bunch more APIs have enums defined for them. But if you hit a case where, like this, the constant or the enum value is just missing, please, file an issue, or better yet, send a pull request to the metadata that adds what's missing. Janema2 asks, is there any hope of the SDK team providing first-hand data beyond the header files? I'm not sure I understand the question there. First, I think, except maybe I'm speculating here that maybe you mean, some people are looking at the metadata as the new header file. And in fact, C# being just one of the projections for this metadata, it is, we have a Rust projection, and believe it or not, there's actually a C++ projection as well. Which at first I thought, wait, C already has these. Why does C need another one? Like, why would in the world would we go from a header file to metadata and then back to C or C++? And the reason that I heard, as I recall, is simply, well, the header files, they lack enums. C++ has enums now, so we could actually do improvements to the C++ story, but you can't go and change the existing Win32 headers that are 2 decades old, because you'll break people's source code when they compile. So it's an opportunity for us to clean things up and improve and use modern C++ techniques even for them. So the metadata becomes not, I wouldn't say the authority. The header files are always the authority, but the metadata would be as close to matching the authority as we can possibly make it. Meaning, could the enums and connected methods be documented along with the headers so that they show up as soon as the SDK team adds new constraint without waiting for the docs to be? That would be great. Yes, I hope that we can come up with better patterns so that when people write the header files, they can be immediately lifted and be accurate and reliable. Yeah. I don't know if there's been talks about doing that yet. Mike or Steve will hopefully be able to, maybe even in the chat, be able to comment on that. So that's the story with enums. It turns out that this same technique, even when enums aren't appropriate, so for example, this is a particularly interesting API. The first parameter is an hwind, and the second parameter is an hwind or a magic constant. So hwind, we're not going to make hwind an enum, but hwind bottom should be a constant. So I don't know if hwind, I think hwind bottom actually happens to already be in the metadata. We could see real quick. Oh, no, it's not. So when we get the scraper to go and scrape all these constants, the other thing it can do is actually pull this out. And even though it won't be part of an enum because this is incompatible with it, at least we'll have the constant defined so that you can pass that in like you would in C. I hope that in every case, in C, or in almost every case, we want C# to be no worse than C is as far as syntax goes. In some cases, C just doesn't need casts, right? Type defs are just implicitly castable. So we add implicit operators and things in C# to try to approach some of that. But in some cases, these header files were designed with C in mind, not C#. So sometimes it's going to be a little more awkward in C#. All right. Let's see. We talked about that. Oh, let's talk about inline arrays. That's just an interesting area. Let's fixed. Let's start with a fixed size array. To be honest, I'm trying to think of one off the top of my head. Let me do a quick search. I know we've been dealing with them recently. And feel free to drop one in on the chat if you've got a favorite fixed size array. Inline array specifically. So yeah, inline arrays are funny things. They're very, very unnatural in C#, but they are possible. And it can be hard to get your head around it. Inline. I'm searching here because I know we've discussed them. Nope, that's not it. I have a least favorite one. If it's a fixed size inline array, then please share it. Otherwise, we'll get to the harder cases in a minute. Oh, RGB. I think that was a good one. RGB. Is it quad? I missed that. Huh. Oh, I'm filtering it too much. That's what's going on. What how that happened? Okay. But where is that used? This can help. If you haven't used ILSpies, of course, I haven't ever figured out why it doesn't always show up. Is there another struct that uses it? Oh, is it? Is it actually Bitmap Info? I don't think that's a fixed size, though. Okay. Well, here's a fixed size one. It's lying. It's actually variable length. But, so real quick, if you have a struct that, let's go back, let's bring back Bitmap Info. If I were to define a struct, because this is really important to understand, especially as you're getting into this, because it requires native memory management. And I need an array of, let's see, what's this called? No, let's not use bool. Let's use, okay, so file name. That's one of the fields in the struct, okay? Actually, this isn't a character array in the struct. What .NET is going to interpret this as is the struct has a pointer to a character array that's on the managed heap. But many times in a .NET struct, that's not what they mean. They actually want a struct that is 128 characters long. And it might be a member, one of many members. So there might be a bool here of, visible, whatever, or read only. You might have fields up and above and below it, but in between two other fields, there's 128 characters reserved in the struct memory itself. And this is not how you represent it in C#. The way you represent it in C# is unsafe, fixed. Trying to remember the exact syntax. 128, I think. Yeah. So it has to be unsafe. C#10 might fix that. Oh, thank you. Thank you. Okay, let's switch to that one because that is the one I was thinking of. JNM2, thank you for that. So if we go to this, and let's look at C# first. So see, this C# makes it look like this is a pointer to an array, but that is incorrect. If you look at the IL, it's actually a fixed size array that is inline in the struct's own memory. So it's never going to be on the managed heap. So we need to be able to reproduce that the way we would do that here. I'll show you what CsWin32 does. Now, we actually make it so you don't have to be unsafe. You don't have to use unsafe, because the way you do it in C# here is you say, okay, well, I have an A, and I want to access, oh, let's put internal in here so I can actually see it. File name. Now, do you see, it's really tiny, but it's a char star. It doesn't show up as a managed array. So you could actually, it's besides the fact that it's a char star, it's actually really easy to use. Let me just tell this all to bug off. But even though you're not using pointers directly here, and I have to actually move this up since I'm using the new C# feature. Even though I'm not using pointers directly here, it's saying, hey, I can't do this outside of an unsafe block. So I actually have to lift this up. And now it works. So I could actually access this array kind of naturally. You know, it's a pointer, but indexer, just like in C, indexing syntax works with a pointer as well. So that's nice, but you do need an unsafe block. Also, this only works for like 8 primitive types, not even all primitive types. So char, int, you know, those things work. But if you had an array of, say, bitmap infos, it wouldn't work. Even though it's a blittable struct, C# in particular won't let you have a fixed length array in a struct of some other struct that you've defined. Can't happen. So that's why over here, jumping back to main AVI header, and notice, if you don't know how I'm doing this, I'm hitting Control-T. I'm putting the caret on the API, and I hit Control-T, which brings up the Navigate To pop-up, and then it'll just jump straight to it no matter what generated file it's in. So if you type, like in the case of create icon, I didn't know what module that would come in. So do I look in kernel 32? Do I look in user 32? I don't care. F12 doesn't work because this is not a code file, but Control-T does. So just, you know, little trick there. But we need we need our fixed size arrays to work for every type, not just the 8 types that C# allows. So we don't use the unsafe fixed array syntax of C#. Instead, this is the one that would be uint with a fixed length of 4. Instead, we define our own private struct. Well, I mean, it's public, so you can access it, but the idea is think of it as an anonymous struct. And then we have one field for every element. So you can actually access each individual field, again, with no unsafe code, no unsafe block, no pointers. And then if you are using C#9, if you're targeting .NET 5, where this, or actually .NET Core 2.0, if you're targeting .NET Core in general, then they define this here, which allows us to mostly safely expose this as a span. So now you actually can treat it as a span of uint and pass it around. You just have to be very, very careful though, because with this warning, there's what people are calling a stack leak. It's possible that the span outlives the struct itself if the struct was on the stack, and then you pop off the stack in return, and yet the span still exists, and that would be terrible. So that's what this warning is about. If you're not targeting, and this is an example of where the source generator can really customize and give you the best thing given your target. Yes, JNM2 corrects me. It's also available in .NET Standard 2.1. Let's do, so this is a multi-targeting project. I'm going to add Net472 as a target. Okay. Now, this generated code is appropriate for .NET 5. It is not appropriate for .NET Framework. So let's see what happens then. If I go back to main AVI header, you notice it's actually giving me, this is the .NET 5 target of it. I can't see what this one is. Maybe this is the .NET 4.7 or the .NET Framework version of it. Yeah. Let's see. No, that's still the .NET 5 version. Let's try something else. I'll just put it here so I can actually go to definition after I change it to .NET 4.7.2. Go to def. Okay, see? The as span and indexer are gone because you can't. .NET Framework doesn't make it safe to create that, even in the you also have heap leaks, basically, where if you added it, it'd probably work when you tested it, but it would fail on your customer's machine and lead to crashes. So we don't want that. So we customize it, and so now the experience is h.dw reserved And then you see this as span with the nice friendly warning saying, look, it's available on .NET 5, but it's not available on .NET 4.7.2. So you could use as span if you wanted to within an if hash if block. So again, that's some of the nice things about the source generator is we can totally customize it for your particular target framework, project, set of references, etc. And like I said, you can drill in and see this generated code in here. I don't know if it's there yet. Oh, it is. Oh, that's brilliant. So this is new. I'm not sure if this is in 16.9 or not. Maybe it's in 16.10. You're looking at 16.10 here. But each individual target framework has its own list of analyzers very, very recently. And then I could have just drilled in here to compare the code gen differences between those two. All right. Variable length arrays and memory management. That's important, and it's hard. For a C# programmer, it's pretty natural for a C programmer. But let's take a look. Let's take a stronger look at Bitmap Info. Because Bitmap Info, despite its definition, which makes it look like there's just one element in the fixed size array, nobody does that. Nobody creates fixed size arrays of 1. They would have just put the element, not defined it as an array. So this is kind of a mnemonic that, or a hint that in the metadata we need to then interpret this as and apply saying that this is a variable length, and then we can do a little bit more help for you. But basically what this is bitmap info header is a header followed by n copies of RGB quad, where n is defined by something in the header. Let's see. So I don't know if it's BI size. I don't know this API too well, but something in here should tell you or tell the native code you're passing it to how many elements are safe to actually access, because at the end of this array is other people's memory that you shouldn't be reading and writing to. So the way you would do this in C#, I'm going to make up some of this stuff, so if you know this API very well, I'm sorry that I might be abusing it, but you get the idea, I hope. So I have a bitmap info. It has to be a pointer. I get strictly, well, you have to allocate memories for it explicitly because bitmap info itself isn't big enough for n items. So let's say you know up front that you're going to need 5 of them. So now you need to allocate memory for it. So since you're dealing with memory yourself, you're going to do an unsafe block and use pointers. P bitmap info equals new. Now this could be managed memory, although we can't use it this way. I guess we need to pin it first. So let's start. Let's see, how should we do this? I mean, I could just use Marshall, but I don't like that. I think let's try fixed. Let's just try doing this directly in here. And I just need, first of all, let's see if it likes this syntax. Oh, I need to get rid of the .NET 4.7.2 target because that's changing my language version. You can do, you know what? Heck with it. I'm going to show you that you can do this on .NET Framework too. It works just fine. Ta-da! Okay. So this will work, but it needs an explicit cast, so that's fine. We'll just call it void star. Or not. Cannot type. Okay, it didn't like that. All right, we'll do it this way. Byte array, let's see, byte. Okay, now it's happy. So now we say bitmap. So we've allocated a buffer of 12. Now 12 isn't actually the right size. What we need is a size of bitmap info header plus n times size of bitmap info. No, not bitmap. But that would get the header as well. Size of this thing, or RGB quad. So let's just do RGB quad, because that's what's getting duplicated. So we're allocating enough memory to store this and n copies of what happens later. And now we need the bitmap info pointer, which we're just going to assign to this. Bitmap info pointer, cast that. And now we can go ahead and initialize it. Now, because we actually allocated this on the managed heap, it's all zeroed out, so we know that everything's already zeros. So we only need to change the things that aren't. So header, let's say that this was, I'm not telling you how to use this API, right? I told you that. I don't know how to use this API, but we're assigning something. ushort. Okay, so we'll I'll cast that, ushort. But the idea is you're going to tell native code how much memory is after it. And then this is where the first element starts, right? That's the first element after the header. And I'm going to go, in this case, I'm going to go ahead and say as span, let's see, is that hard-coded, I wonder? Well, hard-code, ASPAN isn't going to work on .NET Framework, so if we're writing multi-proc code here, I need a pointer to this location. So I'm going to say fixed, and this was a RG quad PQ equals the address of that particular field. Of an already fixed expression. Oh, I don't need it. It's already fixed, of course. That's even better. So now I can just go and initialize them all. I can say PQ 0, RGB blue, very, very blue. The second one should be very, very red. And I had better not do 5 because there are only 5 elements and it's a 0-based index. But this won't. This will AV if I'm lucky. If I'm unlucky, it will stomp on somebody else's memory. And then, while this is in the fixed block, very, very important, while it's pinned, that's when I call the native method. And I pass it PBI. And now it's got what it needs. And I didn't have to do Marshall. I didn't have to worry about freeing memory later because it was actually already on the managed heap. So it'll be reclaimed later. So that's how I would do this, personally. I've been lucky enough to always, I'm reading JNM too. I've been lucky enough to always use Bitmap Info where BMI colors has 0 length. So that, yeah, that's great. In that case, this would be 0. Interestingly enough, this struct is defined to be, not that one. Bitmap Info is defined to be at least one of these long. Turns out that's harmless, so you could just, if you were in that world, you could just say bitmap info, default. You wouldn't have to worry about any managed or manual allocations there. And then you could just pass in. I wonder if this would. Yeah, I don't think you have to use fixed here because, again, it's a local, so it's on your stack, so it's never going to move. And it would be as simple as that. Yes, this is technically more memory than the native code is going to expect because it's not expecting any fixed size elements, but more memory never hurt anybody, right? The other thing you could do, let's bring this back real quick. If you wanted to avoid allocations, as long as you knew that this number was reasonably small, instead of allocating memory on the managed heap, you can allocate it on the stack. So now this whole thing doesn't allocate any memory on the heap, so there's no GC pressure, which is sweet. But it will take a variable amount of stack space, and your threads typically will have, I think, 1 megabyte of stack space. And if you're at the top of a very tall call stack, you don't even have a megabyte to deal with. So don't use stack alloc with high sizes. Like you might, but based on your scenario, you might know. For example, the value of this might be max path, which you know is only, let's see, 260 characters, I believe. Just defining this here so that it'll show up here. Yep, 260. And you know that that's only 260 bytes, and you can afford that on your stack. So now you can avoid the allocation. And then you could encode your wide chars into UTF-8 chars if that's what you wanted to do, for example. All right, I think that about, so let's talk just a little bit about .NET Pinvoke versus source projection. So if you're not familiar with .NET Pinvoke, it is a project that's been a few years old, and it has, for every Win32 module, we've got a NuGet package, not every single one, but for dozens of them, and with varying levels of code coverage. You can see our code coverage report. Like magnification has 10 out of 19, kernel 32 has 157 out of 1300. So it's not great coverage, but it's all handwritten stuff, which makes for decent APIs. We can make them friendlier by hand if we wanted to. You can see here, actually it looks very similar. In this case, we're using out instead of pointers for the out, but we also generate friendly overloads automatically here using a different kind of code generator that's much older than C# source generators. And we have helpers, anyway, but it's all handwritten and it's incomplete. So the future of .NET Pinvoke is probably going to look more like this. All the code's gone. Instead, you have native methods.txt, which is fusion.star. So now we don't have to manage the handwritten code. We're just spitting out the source generator that I just recapped with you over the last hour. So the source generator is now creating this library, but now it's got 100% API coverage. And then we'll still build the package, and you'll still get these with 100% coverage, so you can now choose. Do you want to consume Win32 via NuGet package, or do you want to consume it via a source generator? And I've heard strong opinions both directions. I personally will generally choose the source generator, because then my program doesn't have to ship several more DLLs that might be megabytes of extra space on in my app deployment, and I don't mind running a source generator, which generates the code directly into my DLL or exe. But we'll support both, and because the source generator will eventually be behind this one as well, you could even switch potentially pretty easily if you've looked at the source generator and now you're thinking, well, maybe I want to use a library or vice versa. All the APIs will match up. The namespace or the type might be a little different, but it'll be very, very similar. So that's about it. I guess I'll just show this. I mean, it should be fairly straightforward, I think. I mentioned that you could write your own library if you had several projects that were all consuming source generator, and for some reason you didn't want to run the source generator once for each project. You could do this. So here's my front-end library, or I'll just call this my front-end library. Let's make this public. Oh, it's already public. So now my class library 1 can depend on my CsWin32 sandbox. And so this project no longer doesn't have a native methods.txt, but I still have access to the APIs. So there's HICon, and if I go to definition, it's jumping to the source generated code from this other project. So I could have any number of projects that reference this one. So that's totally fair, a legal use, and that's actually what .NET/Pinvoke, that project, will be doing essentially, except that the project that does it doesn't exist in your solution. This also works if you have a C. Here, let's do one more fun thing. Because the F# crowd, sadly, they don't have a source generator option at the moment, except that they kind of do by proxy, if they can stomach adding a C# project to their solution. So here's an F# project, and I could add a project reference to my CsWin32 sandbox. So you don't have to have any code in this. This could just be a library with nothing but a .txt file inside, right? But then in my F# code, I can say, oops, my goodness, I can't find my enter key. Microsoft I actually expected to see this here. I've done it. It works. Not sure where it went, but you get the idea. maybe it's my context. Maybe I don't know F#. Maybe Microsoft. Okay, well, another day, another demo. But that's the idea. F# should be able to consume a C# assembly. It does that all the time anyway. The BCL is written in C#, so it can consume your native interops from here, although we only have a C# source generator and not an F# one. So I hope that addresses a lot of your questions. Let's see, Mike says, or the pre-built libraries we produce for .NET P. That's true. Yes, F# could absolutely consume those as well. So just to recap, this is an early preview. We're excited. It's on NuGet.org. You can use it today. The APIs are in flux, so if you start consuming this and shipping a program with it that you've adequately tested, and then you update your CsWin32 or the underlying metadata package in your project, it's very possible that you will have source breaking changes, which is one reason I wouldn't recommend you publish a library with public APIs from our source generator right now, because you might have binary breaking changes that you don't want. Source breaking changes are easier to deal with though. So I personally would not hesitate to ship something that depends on this. In fact, some of my projects are already converted over to CsWin32. But if you hit missing or bad APIs, or you feel like something should be more friendly, please do file an issue and we can have a discussion about that and hopefully eventually get it to be as easy as you're hoping it to be, at least for the majority of the APIs. And catch me on Twitter.